Good morning, everybody. I am George Pavlou. I'm the Acting Regional Administrator for EPA Region 2, and I'm ready to announce the dredging of the Hudson River. This river has seen its fair share of history, and today we begin to write its next chapter. The dredging of the Hudson River is a symbol of victory for the environment and for the river communities as well. Today, the healing of the Hudson River begins. This is an historic day for an historic river. Thank you all for being part of it. It's a good day for dredging.
The 315-mile Hudson River is steeped in American history. It guided Henry Hudson in search of a Northwest Passage and served commerce as a transportation route during the Industrial Revolution. Industry provided jobs, created communities, and brought economic growth to the region. Unfortunately, with growth came unregulated pollution. From the 1940s through the 1970s, General Electric plants in the towns of Hudson Falls and Fort Edward, New York, released an estimated 1.3 million pounds of polychlorinated biphenyls, or PCBs, into the waterway. The endurable qualities of PCBs, which made them ideal as a non-ignitable insulator in transformers and capacitors, also make them hazardous to the environment.
PCBs have been extensively studied. They've been studied in human populations. Those are epidemiological studies. They've been studied in animal groups, laboratory animals. And based on that, EPA has classified PCBs as a probable human carcinogen.
PCBs have also been linked to other adverse health effects, such as low birth weight, thyroid disease, as well as learning, memory, and immune system disorders. The first life forms to be affected by PCB-contaminated sediments are bottom-dwelling organisms known as benthic organisms, such as worms, crustaceans, and insect larvae. Through a process known as bioaccumulation, other animals then eat these bottom dwellers and incorporate the PCBs into their own body. During biomagnification, the PCB concentrations then increase as they're carried up through the food chain, ultimately reaching humans and animals who eat contaminated fish. The PCB contamination led to EPA listing 200 miles of the Hudson as a Superfund site in 1984. Fish consumption advisories for recreational fishing were issued in 1971 by the New York State Department of Health. In addition, the New York State Department of Environmental Conservation banned commercial netting of striped bass in 1976. PCBs have also been found in other wildlife, including birds that live along the river's shoreline.
They sampled bird eggs, and the PCB levels in some of the bird eggs that came back were above 50 parts per million. And if something has greater than 50 parts per million of PCBs in it, it is considered, by legal definition, a hazardous waste. So you have bird eggs that are legally considered to be a hazardous waste. And so that just really stuck with me as a, as a severe problem.
We probably have studied that river more than any other river system in the world, certainly more than any other in this country. We, of course, worked very closely with General Electric. General Electric was never bashful or shy about expressing its views or opinions, and they were strongly held and vigorously presented. It's my perception that by being so vigorously challenged by some of the most well-informed people in the world on the questions of PCBs and on these kinds of environmental questions, our science ended up being improved, because whenever scientists are challenged, that's when they do more work, they do more study, and they do more analysis, and they come up with a more robust set of predictions. The determination that we ultimately made to do this dredging was informed and benefited enormously from all of this challenge during so many years.
In February 2002, EPA issued a record of decision that called for targeted environmental dredging and removal of approximately 2.65 million cubic yards of PCB-contaminated sediment from a 40-mile stretch of the upper Hudson from Fort Edward to Troy, New York. The plan divided the work into 2 phases. Phase 1 ran from May through October of 2009. Data from Phase 1 is now being reviewed to determine what adjustments will be required during Phase 2. It's estimated that dredging the 40-mile length of PCB-contaminated river will take 6 years. General Electric, the potentially responsible party for the contamination, agreed to pay for and conduct the first phase of the cleanup, and may agree to perform the second phase as well. Even with the decision to dredge in place, many residents along the upper Hudson were skeptical.
This was an industrial town based around GE. So there's still a lot of loyalty to GE. And the fact that GE is potentially responsible party paying for the entire cleanup, they didn't feel that was fair.
Because of the scope and the ramifications of the amount of controversy associated with this project, EPA felt it was necessary to stage a field office right in the area of concern. So basically, our role is to disseminate information. The local folks often have pointed questions or immediate concerns that need to be addressed, and I'm there. The staff in the field office is there to immediately answer those questions, or at least get them to the people who can help make a difference.
Working closely with federal and state partners, an extensive scientific study and sophisticated project plan was formulated to help overcome the misconceptions that fueled opposition.
Our partners at New York State Department of Environmental Conservation, New York State Department of Health, the U.S. Fish and Wildlife Service, and NOAA, the National Oceanographic and Atmospheric Administration. They've all been very active players. It's been a high priority not only for EPA, but also for these other sister agencies and state agencies that we deal with.
Dredge areas were identified using the results of a multi-year sediment sampling program conducted by GE that generated more than 50,000 sediment samples to pinpoint PCB hotspots. Project planners designed safeguards to protect people's health and minimize local impact during the project, including strict engineering performance standards.
The performance standards include standards for resuspension of PCBs, how much PCB is going to be kicked up into the water column during the dredging. It includes standards for productivity, how quickly can the dredging be done, how much material can be removed during the dredging season. The third engineering performance standard that we established was for dredging residuals, which is the amount of PCBs that remain in the sediment after the dredging is performed in a certain area. The idea being to remove all of the PCBs from a particular area that's being dredged.
PCB resuspension was a particular concern for downstream residents who drew drinking water from the Hudson. To measure for the possibility, an extensive series of upstream, near-field, and far-field downstream PCB monitoring stations were installed. Even with these resuspension controls in place, EPA provided the downstream communities of Waterford and Half Moon, which had drawn their water directly from the river, with a new water line that was tunneled under the Hudson from the city of Troy's reservoir system. EPA also installed a PCB treatment system in Stillwater, another downstream community.
They have a well field which is under the influence of river water. So the concern was that as we were dredging, levels in the PCBs in the river might go up through resuspension. We didn't have enough time to really select a connection to one of the nearby systems in time for the dredging start in May of 2009. So instead, we put a temporary granular activated carbon filtration system in line. The system is considered temporary while we continue to evaluate permanent water supply solutions for the village of Stillwater for future dredging.
To help minimize the impact the cleanup had on local communities, quality of life performance standards were also implemented. including values for air quality, noise, lighting, odor, and the ability of non-project vessels to navigate the river during dredging. The National Historic Preservation Act also required that an archaeological investigation be undertaken.
Indeed, it is a historic area. During the British-French War, there were 15,000 troops stationed in Fort Edward. And as part of the remedial activities, of course, we did find the remnants of the actual fort itself. And sure enough, it was the base of the fort. And those two long pieces of wood are being dewatered so that they would be preserved in perpetuity.
Phase 1 dredging, which took place in the most highly contaminated areas, close to the source of the PCB releases, was logistically complex. GE installed a marina with 30 slips for survey, sampling, crew, and oversight boats, and a traffic control center to coordinate the over 90 vessels on the water.
Yes, we're underway from the 1 Alpha with the skip barge.
Okay, thank you.
A crew of over 500 workers dredged, supported, and processed the PCB-contaminated sediment 24 hours a day, 6 days a week, from May through October of 2009.
The project is pretty big. The amount of vessels on the river, the amount of equipment, the amount of upfront work to get it to be in place to actually implement, it's pretty amazing.
What we did is we used 12 barges, 12 platforms that had an excavator on top. And the bucket that was used is a level cutting bucket. So rather than scalloping that you would expect in any kind of a typical bucket, this actually closed horizontally. These buckets are specially designed for this kind of work. They close tightly. That was a bucket designed for environmental work.
Using custom GPS-guided software, operators were able to precisely remove only material targeted by EPA for dredging. 3 different types of dredge platforms were used, dictated by water depth. To help protect against resuspension, work areas were enclosed or bordered with silt curtains, specifically engineered barriers that float above the water surface and extend to 2 feet from the bottom. Special solar-powered monitors stationed around the dredge area also served as an early warning system by collecting data on total suspended sediments. Once an area was dredged, additional teams were deployed for verification sampling.
We would go in and do a bathymetric survey, make sure that they actually cut everywhere that they were supposed to within a dredge prism. Then we would go in and we would sample, take vibratory core samples, 8 per acre. If we found by analyzing those cores that there was still contamination there, we'd go back in and repeat the process, including the excavation, the bathymetry, and the coring.
Once PCB target levels were finally achieved, a backfill barge moved in and placed 12 inches of clean material over the dredged area to encapsulate any residuals and provide habitat reconstruction and restoration strata.
The cleanup on the Hudson River is impacting a number of habitats for plants, aquatic invertebrates, fish, amphibians and reptiles, and birds and mammals. And because of this, we have to mitigate or somehow address the damage done to those habitats. So we're focusing on reconstructing and replacing or stabilizing the river bottom itself, the underwater vegetation beds, the wetlands that are along the river, and also the shorelines.
Barges loaded with contaminated sediments are piloted by experienced tugboat captains through Lock 7 of the Champlain Canal to a 110-acre wharf, sediment processing, and dewatering facility and rail yard, specifically built for the project in Fort Edward. At the wharf, sediments are uploaded via a large excavator onto a trommel screen, which separates finer sediment from debris, gravel, and rock. The remaining sediment is pumped into hydrocyclones, where grit and sand are removed. The resulting sediment slurry is pumped to a gravity thickener, where polymers are added that allow heavier materials to settle to the bottom. The thickened slurry is then pumped into plate filters, where presses squeeze additional liquid from the slurry, resulting in a filter cake of at least 55% solids. The filter cake material is trucked to an enclosed staging area before being loaded into lined rail cars for shipment to a PCB-approved hazardous waste landfill near Andrews, Texas.
The water from the processing goes to the water treatment plant, which goes through a dewatering process to take any fines that might still be in the water. It goes through a clarifier, goes through multimedia filters, then double carbon filtration, and then a bag filter, so that at the other end it's discharged back to the canal.
As part of the cleanup, the floodplain between Fort Edward and Troy is also being investigated for PCB contamination. More than 2,000 samples have been collected to determine hotspots that require further action. Confirmed hotspots are posted, and areas with direct human contact have been temporarily capped to reduce exposure while a comprehensive study is undertaken. In October 2009, Phase 1 dredging was completed, with an estimated 284,000 cubic yards of PCB-contaminated sediments removed. The treatment facility and rail yard were winterized, and an independent peer review panel began the critical job of evaluating reports submitted by both GE and EPA.
The panel members will review those reports and then, based on the reports, make recommendations as to whether any changes are needed to the performance standards that were set up for the Phase 1 dredging. Does EPA believe that Phase 2 will be performed? Yes, EPA believes that Phase 2 is part of a single project, and it's our expectation that the entire project is going to be done.
The future looks promising for the ecosystem of the river and the residents of the Upper Hudson.
You're going to see better water quality. You're going to see increased land values because of all of this. I think the recreational use of the river will increase. We want to see the PCB levels in the fish get lowered to the point where people can start eating the fish again. There are still people that are subsistence fishing along the river. While people say, well, we'll just tell them not to eat the fish, that's realistically just not what happens. So from an ecological perspective, getting it out of the habitat from the bottom of the food chain right on up is to everyone's benefit.
Once Phase 2 is completed, the community also has the opportunity to transform the water treatment and rail yard site into a profitable transportation hub.
It will probably become the most sought-after commercial site once we are done. It has access by water, it has access by railroad, and of course it's adjacent to highways as well. So it's the best intermodal facility for the entire Northeast, north of Albany.
I think the proof is in the pudding. We think that the first season's worth of dredging was a resounding success. Does that mean we didn't have problems? No, we did. That is in the nature of such a gargantuan project. What was important was that we were able to deal with those difficulties as they arose in a collegial way, in a collaborative way, and make improvements on the fly.
Well, this is one of the most challenging projects I've ever worked on. Its scope, its magnitude is mind-boggling. To think about the amount of material that we have to remove, to do that without having excessive resuspension or air emissions, to do that without having too much impact on the local community, and yet reach our long-term goal of renewing the resource that is the Hudson River. It's a tremendous challenge, and it's a challenge for me, it's a challenge for the whole team, it's a challenge for EPA, and I'm really proud to be a part of it.
The river will get cleaned up. I know it will get cleaned up because it disturbs the conscience. To have the continued exposure to human health and the environment, the aquatic species, the wildlife that are continuing to lay hazardous waste eggs, the folks that are continuing to get exposed. Despite the political shifts here and there, despite GE's decision, despite all those things, it just disturbs the conscience. It will get cleaned up.